We are live on air here on this Google Hangout. So Todd, good to walk through this with you. Just recently met you, and I'm pretty darn impressed by Jscut.
Yeah, and I'm
And
impressed what you're doing with Chilipepr.
awesome, thank you. Yeah, and I'm excited that you and I were able to do an integration really quick. I feel like it only took a couple hours of work there to integrate your toolpath creation from the SVGs, which is always the first step for most folks, and then to just drop it right into Chilipepper so you can go move it forward on your milling. So yeah, with that, go for it and give us a nice walkthrough of this new app you've got.
Okay. Instead of starting with Jscut, I thought we would start with Inkscape because that's really the beginning of the flow. And some of the questions I've seen online were from SVG files that didn't quite meet the requirements of Jscut. So I'm going to explain while going through Inkscape how to create files that do meet its requirements.
Awesome. Sounds like a good idea.
So I wish I had spent time ahead of this to figure out what to draw first. Something to cut out.
Well, I could send you a quick file if you want, or do you got any sample files? Or you could
Well,
just draw a square with some circles in it, like you're gonna mill out a piece of acrylic with four corners, with like a 2 millimeter wide hole or something.
yeah, yeah, that'd work. Okay, so hopefully the screen will flip back where you can see what I'm doing.
So I'm seeing what you're doing, but here, let's go ahead and because I'm definitely seeing your screen.
Okay, I thought it was showing me the broadcast, but right now it's just showing me your face.
Huh, that's weird. Let's try this. Still there?
Yeah, I'm here.
Yeah, maybe hit screen share again on your toolbar.
Okay.
There you go. Yeah, it seems that screen share seems to um, drop off occasionally.
Okay. Okay, so I'm going to start with the Inkscape, and we'll just draw stuff at random to mill out. The first thing I'm going to show is the units because that can easily cause some confusion. So I normally pop this open with a shortcut, but I'll show you the menu instead. The shortcut is Control-Shift-D. But if you go to File, Document Properties, you'll see this little window. This is more of a convenience issue so you don't go wrong, but it's best to change your default units to either millimeters or inches, one of the two, whichever you prefer working with. I normally work in millimeters, but I'll go ahead and work with inches because most people seem to like that.
Yeah, it's funny. I started just doing millimeters too in the last maybe 6 months because I just feel like inches were never the best unit of measurement ever.
Right.
But here we are stuck in a world of both.
Yeah, I can never remember conversions on the English system.
Yeah.
So one thing that's odd, you can see where 0, 0 has, you see the 0 here and the 0 here on the X and Y. That's misleading. SVG's coordinate system, really the upper left is normally 0, 0. And Y goes positive as you progress downward, which is the opposite of CNC machines. So that can cause problems.
Okay.
To demonstrate that, I'm going to go ahead and put down a rectangle. I'm going to put it close to the true 0, 0. And then I'm going to save it. And then I'm going to pull it up in an editor on my other screen and then drag it over. So this is what the SVG looks like. You can see Inkscape likes to stick everything into a group. It uses that for layering. But
Yeah.
you see the actual rectangle has a y-coordinate that's pretty close to 0, even after the translates.
But you're in inches, so it's saying -1.9, so it's actually -2 inches.
No. So it turns out there's this really weird issue with SVG with its unit systems. And it turns out the only way to keep SVGs compatible across all the various editors is for all the editors, no matter what you set your preferences to in the SVG always store it in terms of PX.
Interesting. Or
As,
I've done SVGs where I do no units.
right. So PX is the default unit.
Okay. That is confusing. I noticed in your Jscut interface you do have the PX. You sort of got different menus to try and deal with these issues.
Right. So what happens is three popular editors, Inkscape and two commercial ones that I can never remember the name of because I never used them. Each of the three have a different idea of how many PX there should be in an inch.
Okay.
So if on any one of these three, you draw a 1 inch by 1 inch box, and then you pull that SVG into any of the other two, you'll get a different size. It won't be 1 inch.
Yeah.
So you have to tell Jscut how many PX per inch, and I have a little pop-up that helps you figure out based on which editor you're created it with.
Now I did my SVG that I tested with in millimeter, brought it in, and it worked great. Just kind of in and out.
Right. If you hand write SVG and you stick to entirely physical units and never use PX, you'll be okay.
Okay.
If you ever mix PX and physical units,
all hell
then
breaks
you're in
loose.
trouble.
Yeah.
Because if you, as you bring it into the different editors, stuff will actually shift around relative to each other.
Okay, that makes sense. Okay. Well, I'm excited to see it in Jscut because some of the stuff you did, especially with your 3D rendering, is just really awesome.
So let's do something besides just a simple box.
Yeah.
Let's say I have a box and I'll create a circle. I'll give it a different color.
Yeah.
And let's say, first of all, you can't take this circle as is into Jscut. It only understands path objects. So I'll select both of these objects, I'll do path, and run the object path command.
Gotcha.
Okay, now both of those are path objects. And one of the nice things about path objects is you have all these various operations you can do on them. So I can take these, take the difference between the two, and now I've just taken a circular cut out of my box.
Okay, cool. So that kind of makes me feel like I'm going to mill a piece of aluminum with a little notch out of it.
Right.
A little pocket operation.
Right. And so let's do that. A couple more things. Let's take embed a star.
You're getting really fancy.
And let's say we'll just hang the star off to the side.
Okay, yeah, a little notch.
The star is already a path, so I can just go straight to path union, and now it's combined into one object.
Okay.
And when you're planning out your drawing, you need to think about what you're doing. For every path object, you have several options. You can either tell Jscut to take out the entire filled area, so it just sort of runs the cutter throughout this entire area.
Yeah.
Another option is to run the cutter along the outside of the area, so it leaves a relief.
The outline operation.
Right. And then there's a couple variations of outline.
Cool. Yep.
So let's just take this file as it is and bring it in. I'll save it.
The moment of truth here.
Yep. And then now I'll bring over open Jscut. So this is the main page that it starts out with. and I try to keep a running list every time I add something new. We haven't announced it yet. This stream is the announcement. Pretty soon, popping up on this first element will be the integration with TinyG inside of
Chilipepr.
Chilipepper. I'm sorry
Yep.
about that. I'm terrible
Yeah,
with.
and you know, really, Chilipepr was initially done for TinyG, but it will be available for Gerbil and sort of other platforms. You know, soon, whether it's because I'm doing it or there are some folks in the community that are starting to look at helping because they're liking it. So really, this'll be usable on most milling platforms.
Oh, that's great.
Yep.
So you just from the main page, jscut.org, just hit the launch button, and then up pops the main app.
Yep.
This is entirely running within the web browser. It is not talking to the server on the back end. The only time it talks to servers on the back end is when you're saving and loading settings in G-code, other than on your local drive.
Yep. Yeah, which I think is great. And in fact, I think that's the modern way to build apps here. JavaScript is so capable these days. You don't really need the server to do that much anymore.
Yeah, I'm shocked. Jscut started out as an experiment. I wondered if it could be possible, and then the more I looked at it, the more I discovered, yes, it is.
Yeah, I agree. Okay, so you've got your SVG file local, and then what do you just go to Open SVG? You can't necessarily drag and drop right into the browser yet. I tried that earlier.
Yeah, not yet. Someday I may get around to that.
Yeah.
So right now you just have to open it, and you have several options. You can open it local or from Google Drive or from Dropbox. Even though I'm not going to load from Google Drive, I'm going to just pop that up so you can see what it looks like. And this part here, this widget, was created by Google, and it makes the integration with Google is great. I loved how easy it was to do this.
That is really cool because I haven't done a Google Drive integration yet, but they're letting you search and everything right there.
Yeah.
Oh, it's so nice.
So I'll close that off and then go into my local drive, and I'll go to my desktop. And I named that, I have to get this out of the way, X1.
Exactly. It happens to all of us. So what did I call it? Then I sort by date modified and I cheat.
Okay, so there's the SVG file.
Nice.
And in this case, since we did it's simple, there's one path in this, whereas you can do multiple paths, and with multiple paths allow you to create multiple operations. And maybe we'll get into that a little bit later. If for now, we'll stick with the single path.
Okay. And I notice in the upper right corner you sort of give people pointers on what to do next. So that helped me. That was really important for me because I was like, there's a lot going on here. What's the next thing I do?
Yeah, I'm going to diverge from this a little bit. That way we can explain more what some of these other widgets are, because the tutorial steps skip past some of this because you don't always need to modify some of these other widgets.
Yeah.
So there's two common ways, it turns out, when you're running a milling machine for it to set up your coordinate system. Shapeoko tends to like to have your 0 at the top of your material, but there's a lot of machines out there that tend to prefer that you put 0 at the bottom of your material.
Gotcha. That's why you've got that material widget there. Because I never used it when I was doing mine. I just kind of went with.
Right. Because if the nice thing about the 0 at the top is you don't have to worry about this thickness field. Doesn't really matter. It's more informational.
Yeah.
But it plays a big role if your 0 happens to be at the bottom.
Yeah.
Because that helps you determine where you cut down from.
Yeah.
So like if you have a 1.5 inch thick piece of material, that drastically changes where you're just barely touching the surface when your coordinate system is at the bottom.
Yeah.
I'm going to shift it back to the top because that's the most common system.
Yeah, that does feel the most common. too. You know, even if you're milling PCBs, you treat the top of the PCB as 0. And in fact, that is what I'm going to use your Jscut for shortly, because I'm cutting out pieces of copper for certain shapes to do some inductance to digital conversion detection. And the shape of the copper is important, but you do it from SVG designs.
Ah,
So
nice.
I'm excited.
So during the so now we're back in line with the tutorial, which you click one or more objects, which they have to be path objects.
Okay.
And when you do that, they turn blue, and that's the current selection, and it's a toggle, so you can select multiple paths at once. We only have one, and you can also unselect it.
Gotcha.
The point where it creates the selection is the point where the curve to line conversion happens. So if I unselect it and then make this pretty coarse, you can see the effect it has.
I got you. So it was just doing it automatically because I didn't tweak any of those values, but I see what you're doing there. But you're really just taking the path that was given to you, really in XY coordinates from the SVG, and you're sort of, I don't know, retracing them?
Yeah.
Yeah, okay.
Yeah, because coming from the SVG, it has curves in it, which curves are great. It's great for editing. It's great for some cams that are able to use curves, but the particular libraries I use to construct this thing really can't deal with curves, so I have to convert it to line segments before I can do anything with it.
I see. So when you converted those to paths in Inkscape, it still is not doing it as XY values. It may still give you curve, formulas, not just point values.
Right. In fact,
Okay.
I'll switch back to Inkscape to emphasize it. So I'll zoom in. And here's where you can edit the points along the path objects. And you see these points, they're still acting as
Gotcha.
curves.
They're like little Bezier curves, or yeah.
Yeah, they are Beziers.
Yeah, okay. That's why you got to do it. Cool. Because ultimately you're going to be spitting out G-code of just XY values, so you've got to convert it. That's your curve to line conversion. Yeah.
Right. So after you've had this set up, which the defaults is good for a lot of things, but sometimes it's too coarse for some apps and applications, too fine. There's a risk of setting this too fine. The finer you set, the more points you get.
Maybe you just blow up your machine, or your file is gigabytes.
Right. And I don't know about Durable. I'd never tested it. But some G-code interpreters tend to do really poorly when they have lots of tiny line segments.
Yeah, although it's funny because the 3D printing world, it's lots of tiny line segments, and I feel like there's been pretty good support. I feel like Chilipepr is pretty good at loading huge 3D files, so but it's up to people. They just got to experiment. I think that's fine.
So now we're up to step 3. I've set this back to the original settings, so they're fine for this one. And so you create an operation. We'll probably go back because this doesn't really apply unless you have multiple objects, and we only have a single object in this particular file. But you have several options to choose from. Pocket basically mills out the entire area.
Yeah, there you go.
Outside mills around the outside of it. There's still some things I need to do, like zooming and so forth. If you find where you've done something and it's off the screen, if you just resize your browser window, it'll take care of it.
There you go. Okay. Yep. You could just trigger a window resize event. I do a lot of that in Chilipepr to kind of do what you just did.
Engrave is sort of a weird one. I need to show a better way of showing it, because right now it's hard to see, but this yellow band is where it's engraved. Engraving is neither inside nor outside. It's right on that boundary position.
Yeah, totally. So if it's like a little piece of brass and you're just kind of trying to etch into it, I think that makes sense.
And then
except you're not necessarily showing the width of the engraving on it, because it might be a a point tool or something.
Right,
So the width is really based on the cone shape of the end mill.
right. And then inside, so this out here was the original boundary of our object. This does.
You're doing the inset. Yep.
Now all of these, well, let's see, but the inside and outside, but not the engrave. I'll switch it to outside so it's a little bit more viewable what's going on. There's the this width option. Anything less than the cutter diameter, it just rounds it up to the cutter diameter. Anything above that, and you're adding extra width to it. So if I make it 0.4 and then regenerate it, you see it does that.
I got you. Yeah. Okay, that's cool.
So the black area is approximately the area that we cut out by the cutter. There's a lot of approximation in there, so you have to use the final simulator to see what it really looks like. And then the yellow marks the path that the center of the cutter will take.
Yeah. Yep.
You can see the part of the approximation, it's showing this inside cut, which is impossible with a round cutter.
Right. Yep, so you're just getting as close. And if there's areas where it can't even get in, you don't necessarily throw up like red warning stuff. It's just
it just leaves it uncut.
Yeah.
If it can't fit, it won't cut it. So that's
your Simulate G-Code tab, which I know you're going to get to here shortly. That'll kind of show you some of that too, though.
Yes.
So.
In fact, why don't we go ahead and flip to that just so this point shows up. So
yeah.
we're going to look into this area where the path does this. The preview says that the cutter will do this, which is of course impossible.
Yeah.
But the simulator will show that actually that's not what happens. What happens is
there you go. That's a really accurate view of how to come out. That's awesome.
But we'll come back to this.
Now, is this view WebGL as well, or are you just doing like canvas rendering?
This is manipulating SVGs.
Okay. Yeah, so it's just an SVG object, and you're done.
Yeah.
Yeah.
Yeah. So this black area is an SVG object. This yellow path is a SVG object.
Yeah. Okay.
So you notice I hit this generate link. Both here and here do the same thing. I'm going to make another change. I'll change the width so it shows you. The preview portion of it, the black area, that's a quick computation. So anytime you change a setting, it just updates that since it doesn't take a long time.
And then you got to hit generate toolpath to do the yellow lines.
Right. And in this case, what we have is so simple that it's quick, but there are cases where this may take a couple seconds, so we don't.
That's why you did it.
Yeah, so I don't do that automatically.
Yeah.
So let's go back over here. Let me switch back to Inkscape to better emphasize what's happening here, because this negative y coordinate is probably going to confuse a lot of people the first time they encounter it.
Because when I brought my final G-code in to Chilipepr, I noticed everything was in the negative y space, and it was weird to me. You know, I'm like, I can deal with it, but it was a little weird.
Mm-hmm.
So I'm guessing that's what you're about to show us.
Right, and I wish I had a good solution to this. There's sort of two ways I could have approached it. Both of them have issues. So the SVG spec 00 is really the upper left, and then Y positive goes downward.
Okay. Right.
Whereas CNC machines,
it's the lower left corner.
Can be anywhere you want it to be, and Y positive goes up.
Yeah. Yeah.
So what I did is I wanted to keep it the ability to bring in multiple SVG files on top of each other, and the way to keep them aligned easy is to keep 00 exactly where it's at. So to convert to machine coordinates, I invert Y.
Okay.
Whereas other CAM packages will invert Y and adjust it so that this is 0, 0, so that everything in here will become positive.
Right.
So every time you generate, it generates the paths, and then also in the background, it also generates the G code from the paths, which is a separate hidden step. This shows the result of that conversion, where it shows you the minimum and maximum X and Y coordinates. And you can compensate for this by adjusting offsets here. So if I want to push my Y positive, if I add 50 to it, now I'm no longer negative.
Okay. That makes sense. So I'm going to find that part pretty handy.
So let's see, I've covered everything on the So I've covered everything on the right side, except one thing I've left out was this clearance portion. When the cutter is passing over and not cutting anything,
Yeah.
this is how far above that it's passing. So if you have a bunch of clamps and stuff, then you want to have make this big enough to go over those clamps.
I gotcha. Right.
Back here on this side, back when we were talking about how the different SVG editors have their own notion of how many px there is in an inch,
Yeah.
this is where you have to enter that number. If you don't enter the matching number for whatever editor you used, then the dimensions will come out wrong.
That's why you put some of those popular ones.
Right.
Yeah. Okay. And what's funny is all these Retina displays coming out, pixels per inch definitions are changing.
Right.
So it's getting weird.
Yeah, and the annoying thing is it's called px for a reason. They didn't call it pixels because it's not pixels. It's just some arbitrary unit that at the time they produced the SVG spec happened to be close to a pixel on these various editors.
Oh, man.
That's what you get for a standard that was designed for by committee.
Right. Oh, man. Which is probably why I use unitless SVGs as much as I can.
So, in the future, one of the things that I plan to do is support multiple tools. So you have might have a 1/4-inch cutter and an 1/8-inch cutter doing different parts of the design. Right now, it only supports a single tool. You can have multiple operations, but they all share this single tool.
Yeah, and I like my V-shaped tools with 20-degree or 30-degree or even 60-degree sort of V-shapes.
Right.
So that, of course, starts to be a challenge, though, with your calculations, because depending on how deep you go, the more material you're taking.
Right. So a lot of CAM packages have special facilities for dealing with V cutters. I don't have that yet in Jscut. I'm still researching it. It turns out to really complicate path generation.
Yeah, I bet it does. But for now, and frankly, when tools don't have the V-shape stuff, I just figure out on my own, okay, I'm going to go 0.5 millimeter deep. What's the width of the tool at that? And it just make it work. Or if it's a ball nose cutter, I just kind of figure it out off the widest part of the ball nose. So people can make do.
Right. So the things that affect you the most, of course, the diameter. You brought up a question, and other people have hit this. I do have multiple units scattered around the page. I'm going to go ahead and explain it now since they appear in multiple locations.
Yeah.
The material units sets up where most of the system is based on the material units, except for where it's otherwise. And I just hit a bug. I'm gonna have to look at this later.
Okay. Of course. Of course, while we're doing a hangout on air.
Right. But flipping the units here, it used to flip the units here. That's not happening. The idea was that the material units set up the units across the entire system except for two key locations. Just because you happen to work mainly in millimeters does not mean you have a millimeter tool, because they're hard to find.
Gotcha. That's
So
why.
this is
'Cause I
entirely...
kept switching that to millimeter and wondering why the diameter and pass depth didn't swap.
Oh wow, this is completely broken. I'm gonna have to look at this after this. Okay, it
Okay.
used to be. It used to be when you flip this that all these would change and adjust
That's why I was
amazing.
asking you. I'm like, that's all right. You know what? It still worked though. It still sent it over in millimeters, so I figured it's just not updating the UI.
Okay, so once it's all working correct, I'll probably look at this today, figure out what happened. This affects the entire system except for two key locations. This unit affects only the tool settings. This position, one's also broken, only affects the GCode conversion area.
Yeah.
But this also sets the units coming out of the GCode converter.
Gotcha.
So if your machine is set up for one, make sure you set that to this. I have it set to default to millimeters because that's the way my machine's set up to run.
Although you're just sending the G command to switch units anyway, right? Based on that.
I am, but not all G-code interpreters pay attention to that command.
I gotcha. Okay.
They just blindly assume the units are correct.
Right. But I think for on the Gerbil or on the Tiny G, I think they both support it pretty well, which those feel like the predominant platforms, at least for the maker community, not necessarily for the the real CNC community. These guys that are milling metal.
Right. Of course, they have really expensive systems, so hopefully those pay attention.
Yeah.
So, okay, back to tool. I'm jumping all over the place.
That's okay. You got a lot behind this. I mean, it actually kind of looks unassuming, but it's clear there's a lot of code behind this.
Yeah, there is. In fact, the biggest challenge in developing was trying to figure out how to arrange this so it's not a confusing mess. Because so many CAM systems I've dealt with, parameters are scattered all over the place, and it's hard to find what you need to tweak.
Right. Right, because they're all sort of dependent on each other.
Right. So on your tool, the things you have to usually set up are your diameter and your pass depth. So what happens with the pass depth is you usually end up making several. Well, let me set this to 0, and I'll switch it to make it a little more visible. This is messing it up. I really need to fix the units. And the black area disappeared.
Uh-oh.
Yeah.
Time for a reload?
Yeah, I'm going to have to reload.
When in doubt, reload.
Yep.
And of course, I can't wait until the part where you send your final G-code over to Chilipepr.
That's really cool. That's what we just completed today.
That's so fun.
Okay, so I set this to a single width path. That way I can really emphasize what's going on. Even with this, you usually end up making several passes through this, each time going a little bit deeper than before. This controls how deep, the maximum depth of each pass.
Yep.
So if we set this, say we're going to go 0.3 deep, and each it's going to have to do a minimum of 3 passes.
Right, and on the last path is really where you decide to not do the full 0.125 depth.
Right.
Yeah.
I'll switch to pocket, because that's where it really shows overlap really well.
Yeah. Which the overlap is always important to me when you're doing fine work, because
Oh yeah. So to really emphasize what's going on, I'm going to switch it to a 0 overlap, which you almost never do this because this
wouldn't
causes a
that go
ton of
into
issues.
infinity?
Well, no. So this says that
Oh, right. Zero
each,
overlap would mean your machine's perfect.
yes,
Yeah.
which never happens.
Right.
And it also puts an enormous amount of stresses on the cutter.
Yeah, because you're doing full 100% of the width of the cutter. If you're milling away aluminum,
Oh
it's
yeah, that's
brutal.
very bad. Even on wood, it's not good because you're putting a lot of stresses on the cutter. You're helping to dull it. It's
Yeah.
bending out of its way from all the stresses. You
Yeah.
usually want a good amount of overlap, and it's probably something you have to play with. It also turns out it didn't appear on this one, but it turns out if you go to a 0 overlap on
So
some designs,
you know
it
what's funny? I was inverting in my mind that overlap. I was thinking that an overlap of one was, I'm sorry, 0 was 100. Whatever. I was
yeah,
inverting
you're
it. So.
thinking, yeah, a lot of CAM packages is called step over, and so
Yeah.
overlap is 1 minus step over.
Okay. So I just learned something new there watching you do this. Great.
In fact, because other CAM packages might go back, I might go back and change this from overlap to step over, and then thus
Yeah.
invert its meaning.
Yeah. Or you just give a little popover menu to kind of help explain to people your
Yeah, like I
approach.
have here.
Yeah. Cool.
It turns out there's certain, this one what didn't end up being one, but they're pretty common where if you have an overlap that's too small, it turns out it can't get to certain areas when it's milling it out without an overlap. So you'll end up with gaps that it can't get
Right.
to.
Which you could show in like red or something, but
Yeah.
yeah.
But fortunately, those gaps do show up on the Simulate G-code.
Okay, good. So you are able to double check it.
Mm-hmm. Now we have the speed controls. So when you're rapidly jumping from one part to the nether and you're not cutting anything, this is the speed that it's moving when it's doing that. This only generates G1, never G0, so it's
I
always
gotcha.
has full control over the speed.
Okay. Yeah, because I was thinking the rapids, you just do G0 and then it's up to the user's settings under G0. But either way, that's fine.
And so here, when it's going down, this controls the speed that the plunger plunges into the material.
Yeah, which does matter.
Oh yeah, it matters big time. Go too aggressive like this and you'll ruin a cutter or you'll miss steps or something
Yeah.
bad will happen.
Yeah.
And this one is when it's going horizontally and cutting,
Yeah.
how fast it's doing that.
Yeah. Good. And it's funny because in the simulator in Chilipepr, I don't take into account feed rates yet. It just plays everything at the same speed because that was just too much extra work, but it does make sense to eventually get there. Maybe somebody in the community will modify the simulator.
That'd be nice.
A lot of work.
Yes. Simulators are not easy.
Yeah.
So I think we've covered all that.
Yeah.
Now we'll move down to the operation. For this, I'm going to go ahead and modify the SVG and so we can have multiple operations. That way some of this starts to make a little bit more sense.
Yeah.
So I'll add a circle, make it red. Well, I'll make it, that should show up well. And of course I have to convert that to a path, and then I'll save it. And then I'll restart this. Actually, let me add one more object. That way I have 3.
Okay. Getting fancy here.
How about add a swirl? And the swirls happen to already be path objects. Okay. So I'll make a selection. Let me go ahead and let me do couple more things. Let me start to get a little bit more fancy with this.
And of course, once you're in Jscut, you can't move these objects around.
Right. You can in some packages, but I don't have that facility in Jscut.
Yeah.
Okay, so that I need to convert to path.
Can you just do a select all in Inkscape and just do all of them? Or does it make it individually?
Probably. Let's see. It's not grayed out, so I guess it works.
Okay, cool. I know I've done a lot of just ungrouping and ungrouping to try and achieve my path nodes correctly.
Okay, so now we're back to Jscut with all the new objects added. I'm going to show the Boolean operations, and to really show those, it's best to have overlapping paths, which is why I did this cluster right here.
Right.
So I'm going to do a multi-select and then a create operation. Now, all of those are together in one operation. It defaults to union, so it just treats them as the overlapped area as one. But there are several options. I could union them. I can intersect them.
So that's really cool because I would have just unioned them in Inkscape to then bring them in. I wouldn't have thought to do it in this layer.
Yeah, you can do it either way. There's an advantage. The reason I showed it in Inkscape, there's a big advantage to Inkscape is when objects overlap in Jscut, it becomes really difficult to select them.
Yeah.
So if you have a large object and you're cutting holes out of it and the holes are in the middle of that large object, sometimes they get hard to be select. Sometimes they're impossible to select in Jscut. I still have to work on that.
Yeah.
The reason why I made these overlap have areas that don't overlap is so I could select them easy
Okay.
without hitting that issue.
Right, right.
So the union, you can intersect them. You can take the difference, which takes the first one and then subtracts out all the other ones from it. And then
Which is always
export.
confusing. I never remember what it is. And first one you're saying really in the order of the SVG file that you imported.
It's not the order of the SVG file. It's in the order that you selected it.
Okay. So
I'm going to delete this operation and start it over so you can see. So before this was the first one, and when we did a diff, it chopped these out.
Yeah.
Now I'm going to select this one first.
Okay.
Set it to diff, and now it's chopped these out of this first one I selected.
I would have never figured that out without lots of experimentation.
The best way to do it is to do it in Inkscape. This is sort of a last resort because it happened to be easy to implement with the libraries I was using.
Yep, okay.
So these three controls, well actually these four controls, are all mirrors of this. So it'll show up better if, let's say I start create multiple operations and generate all of them. So now I have three separate operations. Each operation has an entirely independent set of settings. And this is what...
That's what that means, okay.
That's what this means.
Yep.
So this one, say it's a pocket, I'll change this one to an inside and that one to an outside. That way something's different about all three so you can really see it.
Right.
And then the check marks are whether they're visible. The check marks both control whether they're visible, and when it generates G-code, they control what goes into that generated G-code.
Okay. which will be interesting to kind of look at. I mean, it'd be fun to look at the G code and then see how it changes it, because I noticed in your G code you put a lot of good comments in there, sort of based on decisions you made on how to generate it.
Right. That part of it was for debugging purposes, so I could trace down when something went wrong. But also, sometimes for some reason you have to hand edit G code, and it's nice to know where you're at.
Totally agree. And it's why I put attention onto the comments in the G-code viewer in Chilipepr, because they've been important for me in the past a lot.
Okay, so we've covered combine. We've covered operation. We haven't covered direction yet, because it's easiest to see that within the simulate G-code preview what's going on. So let me turn off most of these. I'll leave this one. So when the cutter is sweeping across the object, there's two different directions you can choose. You can either go one way or you can go the other way. The thing that matters is how it impacts the cutter. Is the cutter timming? I can't really explain it without a drawing, so I guess the best way to explain it is look it up. There's online probably some really good explanations of what conventional versus climb milling do, but they do show up in the simulator.
Yeah, because I'm not really sure what they do either, so now you've got my interest piqued.
It does impact quality, and it impacts cutter life. So it's something that if you do a lot of milling, you definitely want to look into.
Right, because it's based on maybe the direction of the threads on your end mill.
Right.
The way the spindle's turning.
Right.
Yeah, okay.
Now, it assumes that you're always using a right-hand cutter. If you're using a left-hand cutter, then you have to mentally flip the two. So with conventional, you can see where it sweeps around this direction. And then if I flip it to climb and regenerate, you can see it sweeps in the opposite direction.
That's cool.
And it's configurable per operation, because when you really start to get fancy, some operations you want to do conventional, and then some you want to do climb. Generally, conventional is better at hogging out lots of material. Climb is better at doing a final finishing pass, but it causes the cutter to deflect a lot, so you only want to do thin cuts on the edge when you're doing climb milling.
Okay.
So I'm also going to change this cut depth so we can see the paths. So each pass depth is 0.125. Right now I have the cut depth set to that. So now I'll bump that up, regenerate, and now when you simulate, you can see how each time it drops down that maximum depth until you get to the final pass.
I love that.
And if you want to start getting detailed, this control has focus at the little rectangle once you drag it. So now I'm using the arrow keys to move it a little bit at a time, so I can.
That's a nice slider tool you got there.
This is one I borrowed. I forgot the name of it.
Yeah, I saw on your GitHub. It's just some kind of bootstrap slider. You're not necessarily showing every G-code step, though. You're just kind of picking.
What I'm doing is I'm interpolating. It would be better to show. Let me delete all the operations. And I'm going to create an operation that will only have a handful of lines of G-code. There'll be an engrave on a rectangle.
Yeah, you'll have 4 lines of G-code.
Right.
But you still interpolate.
I interpolate.
Nice. That's great.
Now, the time that it's showing it on the G-code simulation, assuming you have a machine with infinite acceleration, otherwise it becomes a lot of work to compute the real time.
Yeah, we both took shortcuts in our simulator. Because it's hard.
It's hard.
And really, you got enough there to help people figure out what's going on.
Right. So, Plunge. So this is a relatively new feature. Of course, the whole thing's new, but I think it's like 1 or 2 weeks old on Plunge. So if you notice, by default, it just goes straight down and then starts moving across.
Yeah.
If I enable ramp plunge and regenerate, then instead of going straight down, this puts less stress on the cutter and tends to produce finer cuts. It sort of zigzags its way into the material before it makes its outline path.
That's awesome. Because I've used some other sort of CAM toolpath generators, and I don't recall seeing a feature like that. Unless I just never noticed it.
Back about 10 years ago, when I was using a commercial package, I was using the really cheap version of that package. It didn't support plunging. In order to get plunging, you had to upgrade to the much more expensive package. But just like the G-code and the simulator is interpolating, the ramp plunge algorithm internally is doing some interpolation.
Yeah. So really, the plunge still gets you right to your starting point. It just does some precursor steps. So
Yeah.
You don't even have to really worry about it. It feels pretty automatic.
Yeah. I don't have it enabled by default because I haven't seen that particular option running on a real machine yet over a wide variety of paths, so I don't know if it will always do the correct thing. So that's why it's off by default right now. In fact, I'm going to do another one. I'm going to do a pocket operation with Plunge to show more of what it's doing. It takes the initial part of the path, it follows it, and then it reverses until it gets to the final depth, and then it just continues normally.
That is a sweet feature. Very cool.
And so it does a lot of interpolation in the middle of that, but that's all behind the scenes.
And we were talking yesterday, you're generating massive amounts of triangles in this WebGL viewer to pull this off.
Yes, 1 million triangles. Well, a little bit more than that, but approximately 1 million.
It is just great.
Yeah, I spent a couple of weeks researching on the previewer, trying different approaches. Most of them came out extremely slow until I finally landed on an approach that worked and allowed it to do this, go back and forth and be able to handle it.
Yeah, I mean, I think it's some of the best WebGL stuff I've seen for milling.
Thanks.
It's really good. I'm gonna have to borrow some ideas from you.
Yeah, we'll talk some more. So now I'm going to load it up with some more stuff. Oh, great. And so remember how these checkboxes control what's visible on this view, and they also control what goes into the G-code. They also control what the simulator shows.
Okay.
So you can look into specific paths that are having problems, see what they're doing, or get a view of the whole thing.
So every time you check one of those, you are generating another million triangles.
Every time I rotate the view, I'm generating another million triangles.
Wow. This is awesome.
Modern GPUs are amazing.
Thank God we have modern GPUs. None of this would be possible.
And what's amazing is this is a subset of WebGL is a subset of OpenGL that's designed to run on phones.
Yeah, and I've actually found my Android phone renders WebGL stuff really well. Sometimes faster than my laptop.
Oh, that's amazing.
I just think they're putting great GPUs in those things.
Yeah.
So I'm dying to see this then pump out some G-code to see what it looks like in Chilipepr, because that's a lot of G-code that this would generate.
Yeah.
I presume it would be.
Let's make it a lot. We can make it a lot by, I forgot which one is which.
Because again, you're only generating G1s. You're not generating any arcs.
Right.
So that's just a lot of little straight lines that then feel like curves.
Let's make sure we get a really large number of these things. So let's bump up the overlap.
Well, you just really are going to push Chilipepr. I hope it holds up.
And so even with that overlap, you can see where the preview still works.
Yep, looks beautiful. Okay, so you did a tiny overlap. Okay, yeah. Like a 10% overlap.
Well, it's a 90% overlap. It'd be a 10% step over.
Sorry, yeah, 10% step over. See, I still have my brain inverted on that overlap.
Yeah, I think I'm going to change it to read step over because that's.
Don't do it. Don't do it for me.
So if we go over to save G-code, we have several options. This one we're going to get into in a minute, but you can take your G-code and save it to Google Drive. You can save it locally by right-clicking Get and Save Link As.
Oh, I didn't know that you could right-click that to do the save link.
Or you can just click on Get and it pops open another tab with the generated G-code.
That's what I've been doing, right? And then I do a save as.
So now let's show what the main thing, the reason we're doing this presentation, the Chilipepr link.
It's not the main reason we're doing it. I wanted to do a walkthrough this anyway, but this is definitely a fun part of it.
So I hit that button and it just pushed it to your Chilipepr server. And now if we hit this button, it'll launch Chilipepr. Now this is the part we're still working on it. Hopefully within the next day we'll have it so when you hit that launch button, it'll show the G code that we just uploaded. Right now instead it's showing the G code that I happen to be looking at last through Chilipepr. So if we hit this Jscut widget, we now have all the G code files that I've sent from Jscut to Chilipepr. And so the one I just generated, which one did I just, forgot what I named it. Oh, okay, I just let it as the default.
Yeah, I mean, it should be the one at the top because they're ordered by most recent.
Ah, okay.
And sure enough, it's 127 kilobytes. Look how quick that loads.
Oh, yeah.
And see, you're in the negative space, aren't you?
Yes.
That's what I've been noticing, too.
Yeah, I'm in the negative space because I haven't adjusted the offset. I've reloaded since we did that offset correction.
Right. So see your G1s that are the clearance height? Those I would render in green if they're G0s to kind of show you, but it looks great. Looks perfect.
Yeah, let's turn on, speed it up some and
yeah,
run it through.
Yep.
And it's handling it beautifully.
It is. It looks great. And then zoom. I always like to zoom way into. Well, depends.
Yeah, that probably didn't stream very well.
No, it's looking great. This is so great. I'm gonna be using this so much. I think a lot of people will. And of course, you know, those red lines are just sort of taking that G1 command and sort of showing you the start finish.
Right.
And so you've definitely just generated a lot of G1s.
And showing those individually read like that is probably great for debugging paths that you've generated.
That's why I did it, because you never know what you're going to run into. You start pulling your hair out. Oh, it looks great. Yeah. That's why even following the tool head was a feature I put in there, because I was trying to debug. And if you have to keep trying to manually catch up to the tool head when you're zoomed in like that, it's pretty brutal.
Right. So if I turn that
Yeah,
off,
turn that off,
still.
and then click that View Extents button, that little eyeball. It kind of, maybe gives you more of a traditional view of what it's going to do.
Mm-hmm.
Yeah, it looks great. And then what I think is pretty cool is if I have to go back and make changes in Jscut, I just send it over again and just hit refresh, and it's there.
Right.
Let's try that. What if you adjust the overlap?
Okay.
Maybe go even worse on it, or less. I don't know.
Let's make it harder on it.
Yeah, make it harder.
I love stress tests. Okay, so I have to.
So you have to regenerate all three? Okay.
Right.
Okay.
And I'll go to Save G-Code.
You could even give it the same name, right? And it'll just overwrite the previous one?
We'll see.
I mean, you should just be able to switch over and then hit that little refresh button.
Okay, so that should refresh the list.
And then take a look at the date on it. Yeah, see, 243K now. The last time it was like 125. There it is.
There it is.
Perfect. And you're only going one depth pass here, right? You didn't do multiple depth passes.
Right.
Let's try that really quick. Could you add another, we'll go deeper. Those are the ones I feel like I play with a lot, where I sort of toggle and decide, all right, how many passes am I going to make? So you're going cut depth. Your pass depth is 0.125. Okay, so you're 1 to 0.4, so we'll get 3, right?
I can't do the math that quick in my head.
Oh, whatever.
Or that we can look on the simulator to see.
Exactly.
So 1, 2, 3, 4.
Yeah, the last one is just a tiny little sliver out.
Yeah.
All right, cool. Now let's send that over to Chili. See, I think this is going to be a good workflow process. You do have to hit refresh. There he goes. There's almost a megabyte of G-code now.
There's.
It loads it. Look how quick it loaded it. Nice.
Yes.
Oh, that's perfect. It totally matches your simulator.
It's always good when two separately matched simulators agree with each other.
Exactly. It also means that your G-code you're generating feels good, and my interpretation of the G-code is feeling pretty good.
Mm-hmm.
This is great, and this is all in the browser.
Yes, both of these applications are entirely browser-based.
I feel like this really is a new world of browser apps that we're able to do. If we didn't have WebGL in the browser, neither one of these tools would be here that we're showing off.
Well, only this tab would be available.
Right.
In my case, I only used WebGL for this. So Jscut actually runs on my iPad, although I can't go with these really high overlaps or anything like that, or it just locks it up.
Is it an older iPad or a newer one? Because the new ones have amazing GPUs.
It is, well, Safari on iPad doesn't support WebGL yet. The next major release of the OS will add it.
Okay.
So
which
right
does
now,
kind of show you how early on we are still here with WebGL in the browser.
Yeah.
And I think it's tools like this, like your Jscut or like Chilipepr, that's going to help kind of push things. Where it's like, man, people are creating useful tools with WebGL, not just like games.
And all this came with a surprise. Jscut is my first attempt at a large JavaScript application.
Yeah.
I'm a C++ developer, and I'm used to thinking that
You're
stuff
used to
like this,
creating
you really have to
threads.
go down to the low level to get decent performance.
Right.
Even in even in JavaScript, it turns out if you're careful packing your arrays, which it turns out is a real pain to do in JavaScript, but if you're really good at packing your arrays, you can get decent performance out of it.
Well, how's your memory footprint then of this? How much memory are you using up in your
Is
RAM?
there is there
Just
a
show
quick
this.
way to check in this?
Just the quick taskbar in your
Oh, okay.
for your operating system. That's what
Yeah.
I do because I'm finding that even that stuff you loaded in Chilipepr, you may not be beyond 150 meg of RAM, even with that stuff you rendered. And it's just really impressive how efficient it is. Okay, so but is that including all of your Chilipepr and your Jscut tabs?
Yes, it is. That's what I was wondering. Oh, that's
So
Firefox.
maybe split it in half. Oh, right, you're in Chrome.
Yeah.
No, you're doing Jscut. Do you have Chilipepr in that one as well? I don't think you do. I don't know. But if you're only using 150 meg of
That
RAM for Chrome,
that's weird because Chilipepr is up, and this is Chrome.
yeah, I think you're only using 150 meg for both of those. Yeah, look at that. Which means you're only using 75 meg on average for each one. That is
Hmm.
impressive. If that were a Java app that you had written, it would be chewing up a gigabyte of RAM.
Now, I've also recently started working on Java apps. Not by choice. It's just one of my customers just
Server
prefers
side or client side?
server side.
Okay.
One of my customers prefers Java for some
Yeah.
strange reason.
Well, Java's definitely still a good server platform.
I was able to get not as good performance as I get out of C++. I was able to get reasonable performance out of it by packing stuff into very large arrays and manually indexing them like as an array of structs. Because Java doesn't support array of structs, but if you're very tedious in the way you index into arrays, you can sort of simulate that behavior and get the performance, some of the performance advantage of C++.
Yeah.
And that's kind of what I did on the 3D viewer side of Jscut.
Yeah.
Where if you look into it, you'll see I have these large arrays and index them into really weird ways so that they act like packing objects into arrays in C++ and getting some of that performance gain.
Yeah, makes sense. I mean, we do some tricks. I've done some tricks in the past too, where the garbage collection in Java is kind of brutal. But if you just do things like pooling of objects and reusing them, you sort of bypass things that are frustrating.
Right.
But I would say that the garbage collection in JavaScript in Chrome is impressive. How quickly it garbage collects.
Yes, it is.
It's just great. So it makes me feel, because I was worried too that building such a large JavaScript app would fall apart the bigger it got, and that this would not be a reliable pathway to build a sizable app. And it sounds like you have concluded the same thing, that it really does work.
It really does work. It's more work than in C++, because in C++, I can just define my object types, pack them into vectors, and then the compiler does all the hard work.
Well, sure, but then good luck with a UI in C++.
Yeah, that's the nightmare part, especially on the web.
And then compiling to every platform and building installers and then doing updates when you do new releases. Now people just go to your website. It's done.
Yep.
It's brilliant.
So it looks like in the future, at least for my professional work, looks like most of my work on C++ now is going to end up just being server-side, because JavaScript has proven really capable on the client side, which is something that's been hard for me to admit to.
Yeah, yeah. Okay, well, so I should wrap up here on my side. I think this has been a great walkthrough, really helpful. So, unless there's some other quickie stuff you want to show off.
Couple things. If you just refresh the page, you lose all this work except for the saved G-code, except if you go to saved settings.
Good point.
Just like before, I you can save the settings to either Google Drive or you can right-click and save as.
Yeah.
That saves all the operations, all the settings, everything, except it doesn't include the SVG stuff.
Right, right. So you got to kind of bring that back in.
Yeah. So then to load it back up, then you would open settings, and whichever you pulled it from, and then open the SVG files you worked on.
Yeah. Now you notice in Chilipepr, if you reload, it'll bring back up the last file you imported. I'm just
Yes,
doing the local storage, which it works well, but you do get limited. I think it's only got 5 megs per domain that the browser gives you. But I did that just for that, exactly what you just pointed out, just to kind of make it convenient. But that's fine. I think people will deal with it.
And then one more feature I added. Right now, this one's a little bit of a pain to set up. It can't save to Git right now, but it can load the entire thing, settings and SVG files from a single Git. I mean, not Git,
Cool.
GIST, GitHub
Yeah.
GIST.
Cool.
But that's not for normal everyday use. That's mainly for posting to forums. So you create this link, which you can see on the bottom left what it looks like.
Yeah.
You just have your GIST ID, and then when you start it up with the GIST, you get all the settings you saved plus any SVG files that you put into the GIST. So this is mainly so you have something you created, you want to publish it on the Shapeoko forums or one of the other forums, put it all on GIST, paste this link, and then they can hit that one link and load the entire thing with all your work.
Cool. That's very cool. Yeah, JS Fiddle lets you do that too, where you can pass in that ID and load it, but you can't save back to it.
Yeah, someday I plan to start looking into whether I can do the save back. I haven't looked into detail on that one yet.
Yeah. Really nice.
Thanks.
And then what's any new big features, or you feel like you've got a pretty good coverage now?
I have to refresh my memory. Let me get back to the main page. Got that. That covered that. Covered that. That. Yeah, I think I've covered everything that I've done within the past 3 or 4 weeks.
Great. Well, I think we're looking forward to seeing people do more feedback out there, and whatever comes of enhancements that you make, if you even feel the need. I think this looks pretty darn usable.
Thanks. What I'd really like for now is for people to try it and see how it works on their machines. Give me feedback, give me feature requests, and definitely tell me if you run into any bugs. I don't want to hurt people's machines.
Yeah, definitely. Definitely. Okay, well, good. So good hanging out with you here on a Google Hangout on a Sunday afternoon. I think that was great.
Good hanging with you.
All right, we'll keep in touch and see how the community feels.
Yep.
All right, take it easy.
You too.
Bye.
Bye.